So for the last few months, we've been seeing just how capable these state-of-the-art AI models are at answering research-level maths problems. And because on this channel we ask questions that everyone's wondering but hasn't asked yet, I thought that today we could see whether $200 ChatGPT could explain my recent maths paper to a caveman. Of course, this is something that a lot of people are wondering, and so we're going to be testing the capacity of this $200 AI model, which is like OpenAI's most expensive one for consumers, in explaining a research paper that I've just released with my PhD supervisor and a collaborator, to see to what extent these models really do understand research level maths and their abilities to consequently explain it at a few different levels. First, we're going to be starting with Caveman to see whether ChatGPT could explain anything from this maths paper to a caveman. I mean, I'm not sure actually what you would be able to say to a caveman, but we'll be able to see what ChatGPT would say to a caveman. Sorry, that's so stupid. We'll be asking it to write Python scripts to make visualizations so that this paper can actually be understood by a layman, because you know the Arxiv document is for the suits, you know, the people who kind of do mathematics in a tight suit and need perfect rigor and stuff like that, but really normal people don't want all of those details. And I already have lots of different ways of visualizing these things, which I'm going to show you, but what I'm more interested in is whether ChatGPT will be able to explain these things without being kind of prompted explicitly to do them if we ask it to produce a visual and intuitive document which summarizes this research paper. So buckle up, because we're going to see today whether $200 ChatGPT can explain moments of characteristic polynomials in random matrix theory and its relation to the Riemann zeta function to a caveman. And don't worry, we'll also be testing its ability to explain at higher levels than caveman, so let's go. Okay, so here we are. We've basically given the paper as a PDF to ChatGPT, and we've asked it 3 different prompts. So the first one is the caveman level. We've said you're a research mathematician in random matrix theory and analytic number theory with the clarity, intuition, and pedagogical style of Richard Feynman, who, like everyone knows, is like one of the best explainers of maths and physics, mostly physics, I suppose, but obviously he was pretty well known as a mathematician as well. Your task is to explain and summarize the following paper to a caveman. Write it as if you're trying to make ideas feel obvious and concrete, visual, or however you would if you were explaining this to a caveman. Maybe use like rocks and sticks as analogies and create visual diagrams of this. So obviously we've got to kind of make sure that it is explaining it to a caveman and not just explaining it to a normal person and calling them a caveman. Avoid unnecessary jargon. I think that should be quite straightforward, because obviously a caveman's not going to understand any jargon. I've then outlined basically the main things which I'd like it to summarize. This section here on number 5, like where the Riemann zeta function and random matrix theory correspondence actually shows up, I have a specific thing that I'd quite like it to say, but I'm trying not to explicitly ask it to highlight this point. So we're going to see whether it actually understands the paper. Then on the next one, we've asked it to summarize it for a highly intelligent beginner with roughly the same objectives, although slightly different. And then finally, we've asked it to summarize it for a research mathematician who doesn't actually work in random matrix theory. I will say though, the paper is primarily RMT. It's not that much number theory, so it's not like an analytic number theory paper. So we're going to send these off. There's the caveman one. Here's the beginner one, this last one for the research mathematician, and we'll find out what exactly it does. And I'm hoping these summary documents will be quite interesting to read. Guys, we've had some big news, because if you look right here, it seems as though actually if we look through the 3 prompts, we've got the caveman one here at 73 minutes. We've got the summary for the highly intelligent beginner who like has no background in this. That only took about 60 minutes. The high level one for someone who's actually got experience in maths, that took 50 minutes. So it seems like ChatGPT has put the most effort into the caveman explanation. Rock circles and the Riemann zeta function. I don't think a caveman's going to understand this. They've written order 1. That's definitely not caveman language. Mesoscopic in between, that's fair, and then microscopic. This is a bit disappointing, to be fair. I kind of expected it would actually explain it as if I was a caveman, but it actually seems like it's kind of explaining it as if I did maths, which is a bit disappointing, really. I kind of wanted it to be like, imagine you've got a line with rocks on it, and then you've got a circle with rocks on it, and I don't know, you have another rock. To be honest, I'm not even sure if this would be very clear to a beginner, to be fair. Do they have did we get a diagram out from this? What? There's not a single picture. It did get this right, though. Like, this is quite nice. So this is like comparing, this is statistics of something in random matrix theory, and then this is a Riemann zeta function on the critical line, and you see that they kind of look the same. I mean, to be fair, this isn't the explanation that I would think I would expect to give a caveman. Next, we looked at the summary that it produced for a very intelligent beginner who doesn't have much background in maths, and the story was pretty much the same. It was way too complicated and had way too many equations that there's just absolutely no way a beginner would be able to read this properly. This is maybe a bit too confusing still, I would have thought, for someone who doesn't know any of these words. So does it have a picture? See, none of these things have pictures. I mean, Okay, so here we are. Oh, that's kind of good try, to be fair. I kind of don't feel like it's explaining it in a very friendly way, like to a beginner. So again, not really any pictures actually. So we've got the same picture here. You've got two graphs. One of them's from random matrix theory, where you put random numbers into a grid and do a whole bunch of stuff, and the other one's to do with this Riemann zeta function, which is to do with prime numbers, and they look kind of the same. And other than that, no pictures. No pictures, thank you very much. And the caveman explanation was really not suited for a caveman, and that's the most disappointing part. Finally, the document that was made for a research mathematician with no experience in RMT or number theory, it did a much better job than the other two, but I guess this is much more straightforward given the paper that I'd given it basically included all of that information anyway, so it wasn't really asking it to do anything that was particularly new. So definitely some aspects of some of these documents was pretty cool, but to be honest, when it came to the caveman explanation, I definitely don't think a caveman would understand that. And then when it came to the intelligent beginner, I felt like it used way too much maths. I mean, it was meant to assume that they didn't really know any maths. And kind of all three documents felt like they were more suited for someone who already did maths, maybe who'd finished like an undergraduate degree. And even then, I think it would be quite like a tough read anyway. And there really weren't as many diagrams as I was expecting. Get that on. Boom. So it's the day after, and I realised that actually those three documents were just not good enough. And I think that it's because, at least with regards to the Caveman prompt, it was a bit misleading. So I've set GPT Pro off with another prompt, this time being very explicit that the document should be made for a caveman. And as before, it should include as many pictures as possible. And hopefully it's actually done it properly this time. So it's thought for 79 minutes, which I think is even longer than the time before. This time it said it's going to be diagram heavy, which is good, uses no equations, and really explains the paper with sticks and rocks. The main difference actually is that the prompt is much simpler this time, because this time the prompt is much simpler actually, and is a bit more direct as to what it wants to do. Okay, this is cool. This is way more like what I was expecting. That's really exciting actually. So we've got some pictures. It's a little bit off with the positioning of everything, like it's just not done properly. It's looking much more like what I was actually after. I mean, it's pretty cool that it's able to do this, but I'd say structurally there's some weird things. Okay, so what does it actually get across? The paper studies how violently two famous mathematical beasts wiggle. Oh, I don't know, that just sounds weird. One beast is a giant random circle, I guess so, and the other is the Riemann zeta function. Okay, so a caveman's probably not going to be able to understand the Riemann zeta function, to be fair. I mean, you know, you've got to be realistic with what it's going to do and what it's not going to do. Okay, I'm not sure what this is talking about. So you have a circle and you put a bunch of pebbles on the circle, and then you have this extra, if you like, that you're kind of moving towards the boundary of the circle, and that's in random matrix theory. And then in the zeta function side, I guess there's kind of the pebbles are on this line supposedly, and your probe point is kind of on the safe side, so that's kind of true. So actually the probe point's the same, so you put a pebble kind of to the side, and then you like bring it towards that line. In both worlds, I guess you are kind of like, there's this specified probe point that you're bringing towards this boundary with loads of rocks on it. On the zeta function side, the rocks are the zeros of the zeta function, which are supposedly on this critical line. Think actually of these pebbles as being like charged particles, and this as being like a probing potential, at least on the random matrix theory side. If you put the rock that you're using to like, you know, affect the other rocks on the boundary, so there's a difference between these boundary ones, you don't really change those. If you move that like actually onto the line, that's equivalent to having your probe point on the line here, basically. That's the most difficult case, because the pebbles, because they're like charged particles, they care the most if you're like really close. Now it's explaining what a derivative is. I mean, fair enough. Next was a diagram where it tried to explain something a little bit more complicated to the caveman, but I don't feel like the explanation or the diagram was that good. It was nice to see it try to do it, but with the text all over the place and the explanations fairly limited, it didn't really make much sense. So I thought I'd explain what it was trying to explain properly. So the difference basically just comes from this. So this is in my thesis at the moment, so this is one that I made with the help of the clankers, to be fair, so I'm not going to take the credit away from where it did help. So this is one that I made. So basically this is that circle, and as you increase the dimension of the matrix, you're going to get more of these points on the circle, and this is your probe point Z. So here n is 500, so it's a 500 by 500, if you like, random unitary matrix, but doesn't really matter what that means. Don't need to go into the details so much. All you need to really think, if you're a caveman, is that you've got the rocks on the boundary, and you see as n gets bigger, this boundary rock is really caring about what the next boundary rock, where it is, and if your probe point is closer than the next next boundary rock. It's almost like you've added a rock nearby that's like, puts that rock that was on the boundary here, it's all out of whack. Equally, you could have moved this point towards the circle as you increase n, so this is called a scaling limit, so you actually move z towards the circle, but you do it more slowly than the radius of this thing is shrinking as n goes to infinity. And so that's going to be a different structural behavior than the first one, because you are moving it to the circle, it's just not going that fast. And then there's one where you always move z to the unit circle at the same speed as the shrinking radius. And this is the most difficult one. So these are actually called regimes in random matrix theory. This one is the most simple. It's called the global regime. Okay, they've all got names, but it's not really that important. This is mesoscopic, and then the last one's called microscopic. So the microscopic one's when you're really probing these rocks on the boundary, and you're getting the most wacky behavior, which is actually the one that the zeta functions should exhibit on this critical line where the zeros are. But actually all of this diagram is from random matrix theory. So if you want the equations, this is what it looks like. So I was hoping for something like that. Maybe that was a bit ambitious. But in any case, let's get back to the slides. So keep the probe well inside, so that's the global one, that's where you keep it fixed and you don't move it towards the boundary. Actually, this is cool, so this is a diagram of the theorem one, and this is kind of makes sense. So you put the probe point in the middle. Well, okay, it doesn't have to be in the middle. Again, it could be anywhere, as long as you don't let the point move with the increasing number of rocks, because you're going to start adding rocks in a way. The rocks are like charged as well, so they repel each other. They're not just random rocks. There's a big difference actually between those two things. That would be hard to explain to a caveman. And then there's this, which is one of the theorems, which is where the probing rock goes towards the boundary. This is like a hallucination, I think. In cave language, okay. How the proof works in cave language. So exact many point formula and merge the many tiny probes into one. I don't think this is going to make sense to a caveman, but you know, I don't think equally that you can explain it to a caveman really. I just wondered what ChatGPT would do. The Lindelof hypothesis in cave language, that's quite interesting. A belief that the zeta function does not grow too wildly on the middle trail, so maybe a caveman wouldn't understand that. I mean, yeah, this is like kind of fun, to be fair. It would have been cool if it didn't make these mistakes. Like, this is just horrible to look at, and that it was doing it a bit more properly somehow. Like, you know, something like this, a bit more. It just feels like it could do it somehow. You know, I made this diagram with the help of Codex, so it's definitely capable of making much better diagrams than the ones that it has. But this was after like repeated prompts and fixing it slightly, but it didn't take that many to get it right. So I definitely feel like GPT Pro could have done a better job with these slides, especially with the formatting looking a bit glitchy. All in all, we've created all kinds of documents kind of summarizing this, and some of the diagrams are really pretty. Like, I like this one a lot. Of course, it normally does require lots of equations to describe stuff in maths, so in the paper there are a lot of equations. But I do think that the caveman, you know, reading over the Caveman glossary, I think that it was pretty good at explaining some aspects, like the main idea of what we're doing mathematically. The quality of the document, which is more like a research document, appears to be better than the quality of the document that was made for cavemen. Maybe that's because there's less training data on caveman-style explanatory maths. Who knows? So I hope that you've enjoyed seeing to what extent $200 ChatGPT can explain my maths paper to a caveman. If you'd like me to try and explain my maths paper to a caveman, maybe I'll do that at some point, but it would take me a long time to make the resources to explain it to a caveman. Otherwise, I want to say a huge thank you to all of the channel members, everyone who supports the videos and comments. You guys are great, and as always, I hope you have a good one.